Hello students, today we will learn a new topic in paper first, operational amplifier, that is op-amp. So operational amplifier is it is nothing but a high gain amplifier. It has very high gain and it has two inputs, inverting input and non-inverting input. That is, minus means inverting input and plus means non-inverting input. So this amplifier has two inputs and one output. Okay, and this operational amplifier requires a dual power supply, that is plus VCC and minus VCC. Okay, and this is a single ended output. Okay, so first we will see the characteristics of an ideal operational amplifier. Characteristics of ideal op amp. So its open loop gain is infinite. First characteristic, its open loop gain is infinite, that is AV is equal to infinity. So what is meant by open loop gain? So it is the gain of the amplifier without feedback resistance. Without feedback, the open loop gain is infinite. Second characteristics, its input impedance is infinite. Its input resistance or input impedance is infinite. Then output impedance is zero. Then its input bias current is zero. Then its input offset current is zero, and input offset voltage is zero. Input offset voltage is zero. Input offset current is zero. Input bias current is zero. Output impedance is zero. For ideal op amp, the output impedance is zero and input impedance is infinite. Okay, then the common mode rejection ratio, that is CMRR, common mode rejection ratio CMRR, it is infinity. For ideal op amp, it is infinity. Then frequency response curve extends from 0 to infinite frequency. Okay, so these are the characteristics of ideal operational amplifier. Okay, so what are the characteristics of ideal operational amplifier? The characteristics of an ideal op amp are: first, open loop gain is infinite, input impedance is infinite, output impedance is zero, input bias current is zero, input offset current is zero, input offset voltage is zero. Then common mode rejection ratio CMRR is infinite, and the frequency response curve extends from 0 to infinite frequency. Okay, so these are the characteristics of ideal op amp, ideal operational amplifier. So the operational amplifier, what is operational amplifier? An operational amplifier is a high gain, high input impedance. It is a high gain, high input impedance direct coupled amplifier. So between two stages there is no any coupling device, that is coupling capacitor is not there. The output of first stage is directly coupled or directly connected to the second stage. So this is a direct coupled amplifier. So it is a high gain, high input impedance direct coupled amplifier. Okay, operational amplifier is, it is a high gain, high input impedance direct coupled amplifier. Okay, it has two inputs, inverting and non-inverting. Okay, so negative sign indicates inverting input and plus sign indicates non-inverting input. Okay, then the differential amplifier, first stage in operational amplifier is a first differential amplifier. Okay, it is basically a differential amplifier. Op amp is basically a differential amplifier. Op amp can perform several applications. There are many applications of operational amplifier. It performs several arithmetic operations, like op amp can be used as adder, subtractor, then integrator, differentiator. Okay, again it can be used as an inverting amplifier, then non-inverting amplifier. Then it can be used as a Smith trigger. It can be used as buffer or voltage follower, and it can be used as comparator. Op-amp can be used as comparator. So there are many applications. It can be used in analog to digital converter circuits. Uh, so these are the applications of operational amplifier. Okay, a dual power supply is used for op-amp. Normally IC741 is widely used as an operational amplifier, and it's when input is 0, the output can be adjusted to 0 by adjusting a potentiometer between the offset terminals 1 and 5. Okay, so even if the input voltage is 0, the output is not 0. It will be some in millivolts. So this output voltage should be reduced to 0 by connecting one potentiometer between pin number 1 and pin number 5. That is, between the potentiometer is connected between the offset terminals. So in IC741, pin number 1 is for offset null, pin number 2 it is for inverting input, pin number 3 it is for non-inverting input, pin number 4 it is for minus VCC or minus VE, pin number 5 it is for offset null, pin number 6 it is for output, pin number 7 it is for plus VCC. Okay, now we will first see these major parameters or major characteristics. So what is meant by open loop gain? So open loop gain means it is the gain of the amplifier without connecting feedback resistance or without feedback. It is the gain of amplifier without feedback. So op-amp can be used in open loop mode. Then the gain obtained, it is called as open loop gain, and for ideal op-amp it is infinite. It is infinite. AV, open loop gain, can be indicated by a letter AV. So it is always infinite for ideal op-amp. Then second, input bias current. So what is meant by input bias current? So input bias current is indicated by IB, letter IB. So what is IB or what is input bias current? It is the average of currents, average of input currents, that is IB1 plus IB2 divided by 2 in mod IB1 plus IB2 divided by 2. So it is the average of currents flowing through the two inputs of op-amp. Okay, so it is called as average input bias current. Then what is meant by input offset current? That is IIOS, input offset current, that is IIOS. So what is meant by IIOS or what is meant by input offset current? So it is the difference of two input currents. It is the difference of, that is mod IB1 minus IB2 divided by mod IB1 minus IB2, mod IB1 minus IB2. It is called as input offset current. Input offset current. Okay, what is my input offset current? It is the algebraic difference between the two input currents, that is IB1 minus IB2. Then what is meant by input offset voltage? So input offset voltage, it is indicated as VIOS, input offset voltage, that is VIOS. So what is VIOS? So input offset voltage, what is my input offset voltage? So even if the input voltage is 0, the output should be 0, but practically it is not so. There is some output voltage. So it is necessary to reduce this output voltage to 0. So this is called as input offset voltage. So ideally for zero input voltage, the op-amp output should be 0, but practically it is not so, and this is due to the unbalances in the differential input stage, because in differential amplifier stage there are two transistors. Two transistors are used, but the characteristics of these two transistors are not exactly identical, or these two transistors are not exactly identical. That is, its characteristics are somewhat, there is a difference in characteristics of these two transistors. So there is an unbalance of gain of these two transistors, and therefore this is due to the unbalances in the differential input stage. The two transistors are not identical, exactly identical. So we have to apply small differential voltage to the input of the op amp. We have to apply some differential input voltage to the input of the op amp, and to make the output voltage 0. And the input offset voltage is denoted by VIOS, and this voltage is normally in few millivolt range. Okay, this is this is about input offset voltage. Then what is meant by common mode rejection ratio, that is CMRR. What is meant by CMRR, or common mode rejection ratio? So it is the ratio of differential mode gain to the common mode gain, that is mod ADM divided by ACM. ADM divided by ACM. So it is the ratio of differential mode gain to the common mode gain. It is called as common mode rejection ratio, and it is desirable. The common mode rejection ratio should be infinity. It should be infinity. For an op amp, the common mode rejection ratio is defined as the ratio of differential mode gain to the common mode gain. Okay, CMRR indicates the capability of op amp to successfully reject the common mode signal. So it is the what it indicates, the common mode rejection ratio, or CMRR, of any op amp. It indicates the capability of the op amp to reject the common mode signal. Common mode signal means it is the like noise. Okay, even the inputs are same, that is, when we suppose the input for one input is V1, then for other input it is also V1. Okay, so for example, noise signal, it is a common mode signal for the both inputs. Okay, so this amplifier, that is operational amplifier, rejects the common mode signal. So it is the capability of any operational amplifier to reject the common mode signal. Okay, so this CMRR indicates the capability of op amp to reject the common mode signal. Okay, and it is generally expressed in decibels. It is generally expressed in decibels. So CMRR should be as high as possible. It should be as high as possible. For IC741, the CMRR is 90 dB. For IC741 op amp, the CMRR is 90 dB. dB means decibel. Okay, such a high CMRR helps to reject the common mode signal such as noise successfully. Okay, then what is meant by slew rate? What is slew rate? Slew rate is defined as the rate of change of output voltage. That is dVo divided by dt. It is the rate of change of output voltage. That means how fast the op amp can change the output. How fast, it indicates how fast the op amp can change the output. Okay, so this is called as slew rate. So slew rate is defined as it is the ratio, it is the rate of change of output voltage. It is the maximum rate of change of output voltage. It is the maximum rate of change of output voltage, and it is measured in volts per microsecond. Slew rate is measured in volts per microsecond. Okay, that is SR is equal to dVo divided by dt maximum, and its unit is volts per microsecond. Volts per microsecond. Slew rate decides the capability of op amp to change its output rapidly. Hence, it decides the highest frequency of operation. So, it decides the highest frequency of operation. That is, uh, for higher frequency, the for higher frequency input, the output can change very fast. Okay, so for higher frequency operation, this slew rate, it decides the highest frequency of operation for a given op amp. Okay, slew rate should be as high as possible. That is, high slew rate is desirable. High slew rate is desirable. Okay. Then what is meant by bandwidth? What is bandwidth? The bandwidth of an amplifier is the range of frequencies over which all the signal frequencies are amplified almost equally. All the frequencies are amplified almost equally. It can be amplified. That is, the gain should be constant. The gain of the amplifier should be constant. Okay, so what is bandwidth? The bandwidth of an amplifier is the range of frequencies over which all the signal frequencies are amplified almost equally. The bandwidth of op amp should be as large as possible. The bandwidth of op amp should be as large as possible, and thus the gain of the op amp, it should be constant from DC to infinite frequency. DC to infinite frequency. Then what is meant by gain bandwidth product? The gain bandwidth product, that is GB, is the bandwidth of op amp when voltage gain is unity, when voltage gain is 1. Okay, when voltage gain is 1, the bandwidth of an op amp, it is the product of bandwidth into 1. Bandwidth into 1. Okay, it is the bandwidth of op amp. Gain bandwidth product means it is the bandwidth of op amp when the gain of the op amp is 1 or unity. Okay. The first stage of op amp is differential amplifier with double-ended output. The first stage is a differential amplifier with a double-ended output, and the second differential amplifier it is a single-ended output. So in second stage, the output of differential amplifier is only one, that is a single-ended output. Okay, second differential amplifier has single-ended output. Okay, the output of second differential amplifier is taken as a single-ended output, that is between collector of any one transistor, that is in a differential amplifier. The output is taken from any one collector and ground. Okay, and common ground. Then we will see the block diagram of op amp. Block diagram. So this operational amplifier consists of, we will study about the block diagram of op amp. So this operational amplifier consists of first differential amplifier. Then output of first differential amplifier is double-ended. Then these outputs are connected to second differential amplifier. The second differential amplifier has single-ended output. Then output of this second differential amplifier, it is given to the emitter follower, and output of emitter follower, it is given to DC level shifter, and output of this DC level shifter is given to the output stage. Then this first differential amplifier has constant current source. Constant current source. So the differential amplifier, it is the basic building block of operational amplifier. Differential amplifier is the basic building block of this operational amplifier. Op amp has two inputs. This differential amplifier has this op amp has two inputs, inverting input and non-inverting inputs, and two output terminals. Okay, two output terminals, and this is provided with this amplifier, that is first differential amplifier. It is provided with uh, first differential amplifier. First differential amplifier is provided with a constant current source. It is provided with constant current source. This stage provides, this first differential amplifier provides large gain and large bandwidth. Okay, it provides a large gain and a stable gain. It provides a stable gain, and this first differential amplifier provides large gain and stable gain. Okay, large and stable gain, and it has, this first differential amplifier, it has high input impedance, and uh, this amplifier has a large bandwidth. This amplifier has large bandwidth, and it reduces the noise. This amplifier reduces the noise, and it provides high CMRR. This first differential amplifier, it provides high CMRR. Okay, then output of first differential amplifier, it is given to the second differential amplifier. The second stage is also a differential amplifier, but it has a single-ended output. It has single-ended output. That is, output is taken between any one collector of the transistor and common ground. Okay, then due to these two stages, that is two stages of differential amplifier, large gain is obtained. So large gain is obtained, and CMRR can be, and also CMRR can be, large CMRR can be obtained. Then the third stage, it is an emitter follower, also called as voltage follower or emitter follower. This emitter follower has very high input impedance and very low output impedance. Okay, it has very high input impedance and very low output impedance, and the gain of this emitter follower is almost unity or 1, and this stage acts as a buffer between output and input. That is, it isolates, it completely isolates input from output. Okay, it provides an electrical isolation. Okay, because it has very high input impedance. Okay, and thus, and it prevents overloading. This emitter follower stage, it provides overloading. It provides overloading. Then the next stage is a DC level shifter. The DC level voltage shifter, DC level shifter, DC voltage levels, DC voltage levels of from the cascaded stages are nearly equal to supply voltage. This DC level shifter, what is the function of this DC level shifter? So in an operational amplifier, since there are large number of stages, so these cascaded stages, due to these cascaded stages, gain is increased, and this gain becomes nearly equal to the supply voltage, because there are number of stages which are cascaded, and due to this the gain becomes very large and it is nearly equal to the supply voltage. Okay, and therefore also in the absence of any input, the output may not be 0. Even if the input signal is 0, the output may not be 0, and therefore DC level shifter is necessary to bring the output voltage 0. This DC level shifter is necessary to bring the output voltage to 0, that is to the ground potential. Okay, so the second differential amplifier, emitter follower and DC level shifter, these are the intermediate stage of op amp. Okay, differential amplifier, emitter follower and DC level stage, DC level shifter. Second differential amplifier, emitter follower and DC level shifter. This is called as intermediate stage of op-amp. Okay, intermediate stage, and the last stage is the output stage. Okay, it is normally a push-pull amplifier stage. It is called as push-pull amplifier stage. Its output impedance is very low and it provides sufficient current to the load. This stage provides large current to the load or sufficient current to the load without distortion. This output stage provides sufficient current to the load without distortion, and it helps to supply large output voltage. Okay, this stage helps to supply large output voltage without distortion. That is, it provides maximum current and maximum voltage without distortion. So this is about the block diagram of operational amplifier. It is necessary to explain or to write function of each block, and you have to write function of each block in the block diagram of op-amp. What is the function of first differential amplifier? What is the function of second differential amplifier? What is the function of emitter follower or DC level shifter? What is the function of output stage? So you have to write, or you have to you have to write these functions of all these stages. Okay, so we will stop here.